Okay, class, this is Miss Butel, and I am starting study guide for Unit 7, Part 2. This is 44B for numbers, and I'm going to go ahead and start working these. All right, so first of all, and when I'm doing these, there are a couple of ways. I'm just going to work it the easiest way I can. The fact that I only have two parts right here means that I am going to use solving by square roots. I'm going to add one to both sides. This gives me 4 cosine squared x equals 1. I'll divide by 4. So now cosine squared x equals 1/4. Then I'm going to take the square root of both sides. When you take the square root of an item that's squared, it becomes just cosine x equals, now this side is positive or negative. Square root of 1/4 is 1/2. The square root of 1 is 1, square root of 4 is 2, giving me 1/2. Now this means that x is equal to cosine inverse of plus and minus 1/2. So we have cosine, sine. So where is cosine? Positive or negative 1/2. It doesn't matter if it's positive or negative. It's at 60. It is at, where's the next 1/2 where cosine is? Right here. This is 120. And cosine's negative 1/2 here, 240. And 1/2, there it is, 300. There's our answers. Going on to number 2. This one works identically. Let's just add 9 to both sides. 3 tangent squared x equals 9. Divide both sides by 3. Tangent squared x equals 3. Take the square root of each side, and when you do, this square root cancels with that, giving me tangent x is plus or minus square root of 3. Now look where tangent comes out to plus or minus the square root of 3. Forgive me, I am going right through this and I'm pointing these out and I didn't even rewrite it. X is equal to tan inverse of plus or minus square root of 3, and I have found all of those answers. X is equal to, they're all underlined, 60, 120. It looks like all the same ones. Seriously? It sure is. 240. I guess we like those. 240 and 300. All right, moving on down the page. This one, I have a GCF of sine x. Now, you can think of the GCF as we are dividing it out, and then what's left is, okay, when I pull it out in front, it's going to look like this. And what's left in the middle, well, sine x divided by sine x is 1 minus this cancels because the sine was pulled out front. So it's 2 cosine x equals 0. Now, I want you to notice that if you were to multiply this back through, you would get exactly what you had right here to start with. So I don't want to multiply back through. I'm just saying if you did, that's what would happen. Now, we have to have both pieces equal to 0. So I get sine x equals 0, or x is the inverse sine of 0. Okay, so does sine get to be 0 somewhere? Well, yeah, here and here. So it's going to be at 0 and 180 is what x is equal to. Then we're also going to see what happens on this other side. I'm going to subtract 1 from both sides. I get -2 cosine x equals -1. Divide by -2. Cosine x equals positive 1/2. So x is equal to inverse cosine of 1/2. So notice this is not positive or negative, it's only positive. So cosine is positive 1/2 here, and cosine, remember all stairs take caution, cosine is positive down here. There it is right there. So we have 30, 60, and 300, excuse me. All right, going to the next one. This one's a little different because I have cosine squared x and a cosine. Oh, no, it's still the same. Sorry, I was thinking I had 3 terms. I only have 2. So what I'm going to factor out here is cosine x. So that means I pull up front cosine x times something is 0. So let's see what we're going to have left in here. I've got a 2 and a cosine left. 2 cosine x. And all I have left here is a square root of 3 minus square root of 3. So I'm going to set both of these equal to 0. So here, cosine x equals 0. So x equals inverse cosine of 0. And where is cosine 0? This is cosine. Cosine is 0 right here. And cosine is 0 right here. So this has 2 answers, 90 and 270. Not always the case when they end up like that. Okay, this is what x is equal to on this side. On this other side, I'm going to add square root 3. And I'm going to have 2 cosine x equals square root 3. Divide by 2. And I get cosine x equals square root 3 over 2. So x equals inverse cosine, or cosine inverse, I should say, of square root of 3 over 2. And it's only positive. So again, it can only be these 2 quadrants. So there's the square root of 3 over 2. Here's the square root of 3 over 2. So this is where x is equal to 30 and 330. All right, 4 answers. 4 answers. But do realize you could end up with no answers. You've got to be careful going through these. All right, going on to the next one. This is not equal to 0, so I have to pull this over to the other side by subtracting it. All right, so what I'm left with is secant x cosecant x minus 2 cosecant x equals 0. Guess what? I have a GCF. Here it is, cosecant. So I'm left with cosecant x times secant x minus 2 equals 0. Let's set both pieces equal to 0. Cosecant x equals 0. And guys, this is the same as it being over 1. The reason I'm doing this is because I'm going to turn this guy, any of these cofunctions have to be turned into fractions. 1 over sine x is the same as cosecant equals 0 over 1. So that means sine x equals 1 over 0. Guys, that's undefined. So there's no solution here. That's the empty set. This side, I'm going to add 2 to both sides. That was an arrow, sorry. So I end up with secant x equals 2. And so remember, this is over 1, and this becomes 1 over cosine x equals 2 over 1. So now I'm going to flip both pieces. These flip. So cosine x equals 1/2. So where is cosine 1/2? And it's only positive, so it's there and here. So that's at 60 and 300. This had only two answers. X is equal to 60 and 300 degrees. This had no answer, so that first piece, it doesn't happen, okay? And that's okay. All right, so on this one, this is the first one that has 3 parts. 1, 2, 3 parts. So right away, this is going to be one where I want to do a diamond to solve it, so I have to substitute. I'm going to let n equal sine of x. So this would actually look like n squared minus 3n plus 2 equals 0. I'm going to do a diamond. Remember, AC goes on top, B goes on the bottom, over n over n. There is only a 1 that's understood in front of there, and I don't write ones. Okay, so AC is 2. This is -3. And I have to multiply to get the top. So 2 times 1 are my only options. And that does give me +2. But when I add them, 2 plus 1 is +3. So that means they both have to be negative. Now it works. So what I'm left with, this becomes n minus 2 times n minus 1 equals 0. Well, we don't really have n. What we really have is what it says up here, that n is sine of x. So where all of these n's are, it has to be sine of x. So sine of x minus 2 times sine x minus 1 equals 0. Now, I'm going to let both parts equal 0, and I'm going to go ahead and add 2 to both sides. So sine x equals 2. Wait a minute. That can't happen because sine of x is never 2. This one is the empty set. This one, sine of x, adding 1 to both sides. Sine of x equals 1, so x equals inverse sine of 1. And sine being 1 would be this piece being 1. There it is. Is there a 1 anywhere? There's not. Okay, so that means x is equal only to 90 degrees. And we're done. Interesting, huh? You can have a no solution, 1 solution, 2 solutions, 3, 4 solutions. All right. Next page. All right. On this one, you have tangent and tangent. There are not 3 parts to this one, so we don't have to do a diamond on this. But I do see that tangent x is part of both pieces, and that, my friends, is my GCF. So this is what's going to come out front, tangent x times cosecant x minus 2 equals 0. Guys, I'm factored. All I had to do is take my GCF. So set both pieces equal to 0. So tangent x equals 0. Now, if you decide to take this shortcut and you're going, okay, so where is the 0? Here's where tangent 0. Here's where tangent is 0. Oh, I got my answers. They're at 0 and 180. So 0 degrees, 180 degrees. This side, adding 2 to both sides, I have cosecant x equals 2, and we're going to make it over 1 because this becomes 1 over sine x equals 2 over 1. Now we flip both sides. So that gives me sine x equals 1/2. It does not give me 2 anymore. All right, so x is equal to the inverse sine of 1/2. So where is sine a half? And it's positive. Be careful. It's positive here and it's positive here. So this is at 30 degrees and 150. Next one. This one, be careful. We have 1, 2. Here's my third part, but it's got to be equal to 0, not to 1. So what happens is I have to move this to the other side by subtracting 1, and then this side really does become our 0. So I'm going to have 2 sine squared x plus sine x minus 1 equals 0. Now I have my 3 parts, and this is where I want to let n equal sine x. So now it looks like 2n plus n minus 1 equals 0. Set up my diamond. AC goes on top, which is -2. B goes on the bottom, which is 1. It's an understood 1 right there. All right, so be careful. This is the part where, and that should be a squared. This is the part where we use the 2n to go on the bottom here and 2n to go on the bottom here. What multiplies to give me -2 is what goes up here. Well, the only factors of 2 are 2 and 1. But 2 times 1 is not -2. I need it to be negative, and this is positive. So one of these two have to be a negative. If I take 2 minus 1, it gives me positive 1. Had the negative been in front of the 2, it would have given me -1, and that would not work. So then you have to double check, will any of these reduce? Well, yes, this becomes 1. Final answer is n plus 1. This is final for the factor, and 2n minus 1. Well, we really don't have n's. We really have sine of x. So I'm going to substitute back in sine x plus 1. 2 sine x minus 1 equal 0. I'm going to set both pieces equal to 0, and I get sine x equals -1. So where is sine of x -1? Well, sine is on this side, and this is the only place right here. X has to be 270 degrees. Other side, let's add 1 to both sides. 2 sine of x equals 1. Divide by 2. I get sine of x is 1/2. Now, I'm just going to go ahead and look for where is sine 1/2. Sine is positive 1/2 here at 30, and it's 1/2 at 150, and that's what I need. So x is equal to 30 degrees and 150. By the way, just so you can see this, if you do, no, I don't want to. Let's go ahead. Let's just keep going. And I will show you a way to check some of these on the calculator. I just don't want to do it yet. I don't want to run out of time. This is my second time to record this, and running out of time is not fun for me. This only records so many minutes. So I added 1 to each side because I want this side to equal 0. When I do that, I get 2 cosine squared x plus 3 cosine x plus 1. I've got 3 parts, so that means I cannot keep a cosine in here, at least, and have it make sense for everybody. So I'm going to let n equal cosine of x, so this becomes 2n squared plus 3n plus 1 equals 0. set up my diamond. 2 times 1 is 2. B is 3. The front is 2n. The back is 2n. The only factors of 2 are 2 and 1. And 2 plus 1 is 3. So this is set up perfect as is. It's just this reduces to 1. So this is 1 over n, which is n plus 1, and 1 over 2n, which is 2n plus 1, equals 0. Now really, n is cosine of x. So I'm going to replace the n's with cosine of x. So cosine of x plus 1 times 2 cosine of x plus 1. And I'm going to set both of these equal to 0. All right, so I have minus 1 to both sides. I have cosine x equals negative 1. I'm going to minus 1 to both sides here. I get 2 cosine x equals negative 1 divided by 2. Now on this one, I have cosine x equals 1/2, and here I have cosine x is negative 1. So where is cosine negative 1? Cosine is negative 1 only here. That's only at 180 degrees. And here, cosine is 1/2. In fact, it's negative 1/2. So here's a negative 1/2, and here's a negative 1/2. So this one is at 120, and here it's at 240. All right, next one. This one, we want to move both of these over to this side because we want our squared term to stay positive. So this is going to end up being cotangent squared x plus 2 cotangent plus 1, because that's what I would have to do to this side is do the opposite, equals 0. Well, guys, it's not okay for me to do this with cotangents. It's much easier with a letter. So I'm going to say let n equal cotangent x. So now I'm going to have n squared plus 2n, and I just realized the x was gone there, plus 1 equals 0. All right, this gives me 1, and this gives me 2. So 1 times 1, and this is over n. Would you look at this? I end up with n plus 1 times n plus 1 equals 0, or n plus 1 squared equals 0. All right, so, but we don't just have n, we actually have n is the cotangent of x. So cotangent x plus 1 equals 0, and I'm going to take the square root of both sides. When I take the square root of both sides, this cancels with the square, and I have cotangent x plus 1 equal plus or minus 0, but it's 0. This is the only time that plus or minus doesn't matter because 0 is neither positive or negative. So minus 1 to both sides, cotangent x equals negative 1, but cotangent is the same as 1 over tangent, and going over 1, it doesn't change anything at all. So tangent x equals negative 1. Where does tangent x equal negative 1? Here and here. Those are the two places that tangent can be negative, so that makes sense. So this answer, x is equal to 135 and 315. Looks like we just rearranged those numbers. Great numbers for dyslexic. All right, there's our two answers, and we may be done. Yes, we are done. The end. Guys, have a great night. I hope this helps.